Okay, so our first lesson for the year is going to be solving one-step equations. This is chapter 1, lesson 1, and it should be review, so I'm not going to, go too slow here. I think that we just need a little refresher and then we'll be ready to go. One-step equations essentially implies that only one operation was done to the variable, and therefore there's only one operation we need to undo with that inverse operation to cancel that out. Okay, so what allows us to do that to solve equations, by the way, are some pretty important properties. You've got the addition property of equality, the subtraction property of equality, and on the other side you'll see the multiplication and division properties of equality. And these allow us to solve equations because essentially they state that either adding, subtracting, multiplying, or dividing the same number on each side of an equation produces an equivalent equation. So if we've already established that two things are equal, then I'm allowed to add the same quantity on both sides or subtract the same quantity on both sides, and the equality is preserved. It's still a true statement and it's still equal, okay? So that's the big idea behind that. So let's go ahead and get started with number 1 so you can just review how this is done. So these are pretty simple, but pretty soon we're going to have some pretty complex equations that we're dealing with. So always keep your eye on the prize and make a note, okay, there's my variable. That's who I'm trying to get alone or isolate. And then think about what operations they did to that variable that you have to undo, okay? So if I look here, I have x here on the left side. I noticed right away that they added 7, okay? And so that's what I want to undo because we don't know what x is yet, but we know that when we added 7, we ended up with negative 12. So if I could just reverse that step or undo that, then I would get back to this original value. That's the idea. So the opposite of adding a 7 or combining with this positive 7 is to apply a negative 7, okay? Now, that's where the subtraction property of equality comes in. The only way that I'm allowed to do that is as long as if I do it on the left, that I make sure that I also do it on the right side. So you can think of this as like a balance. The original statement was already perfectly equal and balanced. If I take away 7 on one side, that's going to throw off the balance of things as long as, unless I make sure that I do it on the other side so that the balance, maintains. So yeah, they were combining this with a positive 7. We're going to then apply a negative 7 because we know that 7 minus 7 is 0. Or in other words, these are exact opposites and they cancel. And then that allows us to have x all by itself, which is exactly where you want to end up. And on the right side, negative 12 being combined with a negative 7. Those are both negative, same sign. We're going to find that sum. That's going to be a negative 19. Okay, and I'm feeling really good about this answer, but just remember, one of the most underutilized options you have is checking your work, being able to plug that back in and rewrite this top equation, and instead of writing x plus 7, you can write negative 19 plus 7, negative 19, plus 7, equals negative 12, and find out, is that still a true statement? Is the left side still equivalent to the right side there? Well, negative 19 and a positive 7 do give us a negative 12. So indeed, this is still an equation that is true. So that's something that I'm not going to necessarily ask on every single practice problem, but you should be prepared to do it if I ask. And more importantly, it's just a wise, common sense, good thing to do, especially on major assessments like tests, learning checks, quizzes, things like that. So I would think that that's something you want to take advantage of. Okay, let's try number 2. You've got negative 15 plus w equals 6. So that w is being combined with a negative 15. Be careful not to look at this middle sign. You're looking at what's in front, right? Because what's really going to cancel a negative 15 is a positive 15. Okay, that's how we're going to be able to cancel that out and zero it out. Okay, and if we add a positive 15 on one side, we got to make sure we do it on the other side. This will become 0. W's by itself, and 6 plus 15 is 21. Okay, so far it looks good. Let's try number 3. On number 3, we're looking at negative 2 equals y minus 9. So our variable this time is on the right, And the operation that they're doing is -9, or in other words, they're combining that with a -9. And the opposite of that -9 is a +9. So we'll make sure we do that on both sides. This will cancel. Y is by itself on the right side, and on the left, our new result, -2 + 9, or -2 and a +9, is just +7. You can test it if you want to be sure it works, and then once you're confident and you feel good about it, you can box that answer. I should have boxed all my answers. Let's back up here. By the way, one of the advantages of our notes being done together like this is that I'm going to be modeling exactly the level of work that you should be showing. So if you're ever in doubt, does she expect me to show this or does she expect not? Look at the way that we're doing our notes, because this is exactly what I'll be looking for. There's some things that I'm okay with you just doing in your head, like being able to combine those in your head. You don't have to like show that off to the side, but you do have to show that inverse operations on both sides and how you got the 21 and so forth. So whatever I'm modeling here, this is exactly what I'll be looking for in your work for credit. Okay. All right. Number 4. On number 4, you have a fraction, but that's okay. Remember, fractions are our friends. I'm going to totally convince every one of you that fractions are better and usually really helpful. By me, at least. And there's also good news here because we already have a common denominator, so that they were nice about it. But let's go ahead and solve here. There's our t variable. They're combining that t with a +3/2. So the opposite or the inverse of that is a -3/2. That's what's going to cancel that fraction. If we do it on one side, we have to make sure we do it on the other side. So there's that. Now t is alone on the left, and here, like I said, they were at least nice enough to give us a common denominator. So all I have to do is combine those numerators on top. +1 minus 3 is a -2, and then the common denominator stays. Okay, and as much as I love fractions, and I do think they're easier, do not leave things unsimplified. I would not accept this answer. I would want you to look at that and say, oh, wait, -2/2, that does simplify to -1, and that's your final answer. Okay. All right, on number 5, another little bit of a trick here. Be careful with this one. Remember, variables are letters. You know, they're either alphabetical letters or Greek letters. You know, variables usually stand as letters. This is a symbol, but it represents a constant. This is pi. It represents that lovely number, 3.14, so on, so on, so on. So be careful not to assume or think that this is your variable, because it is not. I know it looks like a symbol and not a number from 0 to 9, but it is actually a number. So this is a constant number, this is a constant number, this is a variable. F is who we're trying to solve for here. That's our variable. Okay? And they are combining that with a +3 pi. So the opposite of that is a -3 pi. And we'll have to do that on both sides. It'll cancel here. I'll get F equals. And then because these are both pi terms, I really can combine them kind of like you would combine like terms. If I have 7 pi minus 3 pi, that leaves me with 4 pi. Okay, please do not reach for a calculator and go try to actually compute what that is and give me some decimal answer. If they gave it to you originally in terms of pi, you can leave your answer in terms of pi and just say, yeah, you know what? F is 4 pi. Okay. All right, so hopefully that was a quick review on just how to solve those one-step equations with addition and subtraction. Let's try a couple of word problems. Number 6 says the balance of an investment account is $308 more than the balance 4 years ago. So there's right now at least 2 numbers we don't know. We don't know what the balance is now, and we don't know what it was 4 years ago. But we do know that the new balance is $308 more than it was 4 years ago. Then it does reveal one of those answers. It says the current balance in the account is $4,708. So what was it 4 years ago? So this is what we're looking for. Okay, so we're going to call that our X value, the balance 4 years ago. And what do we know about that balance? Well, we know that the new balance, this $4,708, is $308 more than what this was. So if we go back to that more than, we know we have to change the order. So the balance 4 years ago plus $308 gives us our new current balance of $4,708. So there's our equation. This is what I would be looking for. It's probably the most important piece of this. Translating this into the equation, that's kind of the first big step. Then after that, step 2 is solving. So now that I know that this is our setup, if I want to find out what the balance was 4 years ago, all I have to do is take back those that $308 increase that I know has occurred. So I'll just subtract that out to find out how much did we have originally before the increase, right? So this cancels. So x is left alone, and on this side, 8 minus 8 is 0, 0 minus 0 is 0. 7 minus 3 is 4, and 4 minus 0 is 4. There it is. So the balance 4 years ago must have been $4,400. And my expectation is when you have word problems that you actually give a full sentence answer. When someone asks a question, you answer it appropriately, right? So if it says what was the balance 4 years ago, we would say the balance was $4,400 4 years ago, or something to that effect. It doesn't have to be a long dissertation, just a simple but complete answer. Okay, let's look at number 7. So it says you and a friend are playing a board game. Your final score, X, is 12 points less than your friend's final score. So here's my friend's final score, 195 points, sorry. Write and solve an equation to find your final score. So this is your friend's, and you know that your score is